when we use triangles to explore the properties of angles, we're limited in terms of the angle measurements we can look at, because it's not possible to draw a triangle that has a 180-degree angle in it, for example. So if we want to examine angle measurements for all angles or other angles other than what can be represented in a triangle, we need another way to represent those angle measurements. And one way of doing that is looking at angles in the Cartesian plane, so the x and y axes. And these are referred to as angles in standard position. Now, for an angle on the Cartesian plane in standard position, there's a little bit of new terminology that we need to get through. So first of all, the vertex of this angle, which would be this point right here, okay, that vertex lies on the origin of the Cartesian plane for angles in standard position. Okay. The initial arm, right, in this picture is the blue arrow here. That initial arm of the angle, meaning the starting point of the angle, lies on the positive x-axis. Okay. And what's called the terminal arm is the other arm of the angle that is rotated away from the initial arm. So the terminal arm is rotated away from where the initial arm started in order to create some angle. Usually we call that angle theta, although we could use some other variables to describe that angle as well. Okay, so this is what we mean when we talk about an angle in standard position on the Cartesian plane. We have an initial arm on the positive x-axis. A terminal arm has been rotated a certain number of degrees from that initial arm in order to form the angle that we want to take a look at. Now, using this idea, we're not limited by the angle measurements that can be used to create triangles, because we can rotate this terminal arm as far away from that initial arm as we want to and create angles up to 360 degrees if we rotate all the way around, or even beyond 360 degrees if we keep rotating. We can actually also create negative angle rotations by rotating in the opposite direction. Okay? So what we see in this first diagram is actually called a positive rotation. A positive rotation happens when the terminal arm is rotated in this direction or in the counterclockwise direction. Okay? So the opposite then, for a negative rotation, that's when our terminal arm would be rotated in the opposite direction, which means in the clockwise direction. Okay. So here's a couple of examples. If I were to look at this angle here, being angle theta, okay, this would be a positive angle theta because it's rotated in the positive direction or in the counterclockwise direction. This is a positive angle or positive rotation. Whereas if I start at the terminal arm, or sorry, start at the initial arm and rotate this way to get the terminal arm there, this would be a negative angle measurement for theta, or negative rotation. Okay, if we're looking at our Cartesian plane, so our x and y axes, the Cartesian plane is divided into 4 quadrants. Now, if we were to number those quadrants, we would start with the quadrant where x and y are both positive. That's quadrant 1. Okay? Rotating in a positive direction or counterclockwise, this would be quadrant 2. This one's quadrant 3, and this one's quadrant 4. And they're given Roman numerals to represent the 4 quadrants. Now, the x and y axes are actually represented by angle measurements, because if we have our initial arm on the positive x-axis, right, and we rotate, okay, if I rotate that initial arm to the positive y-axis, that would be an angle measurement of 90 degrees because I form a right angle here. Okay? If I rotate another 90 degrees, my terminal arm would be at 180 degrees. If I rotate another 90 degrees, I'm at 270 degrees if my terminal arm is located on the negative y-axis. If I keep rotating another 90 degrees, my terminal arm would end up right back at the positive x-axis, and so I would have rotated a full 360 degrees. Okay? Now, it is also possible that my terminal arm doesn't rotate at all from the starting position. So the positive x-axis would actually also be referred to as 0 degrees. Okay? I could keep repeating this pattern. So if I rotate another 90 degrees, I would be at 450 degrees. Okay? Keep rotating another 90 degrees, and I can keep doing that. And I can actually have the terminal arm in the same location, but have different angle measurements that represent that terminal arm, depending on how many times I've rotated fully around in 360 degrees first before moving to that terminal arm. This is what's called coterminal angles. And coterminal angles are angles that have the same terminal arm, same position of the terminal arm, and the same initial arm, but it might mean that I've rotated around a different number of complete times. So here's examples of terminal arms. So here is the angle theta 1, okay? And so we've got our initial arm on the positive x-axis. We've got our terminal arm that's been rotated in a positive direction, okay? And I'm telling you, in this case, theta 1 is 120 degrees, okay? In the second picture, we've got the exact same terminal arm, okay? It's in the exact same position, but the difference now is that this terminal arm has been rotated all the way around once, so 360 degrees, plus that same angle measurement from before, so plus 120. So theta 2 is actually 360 degrees plus 120, right? Because we've gone around one full time and then another 120. And so this angle measurement, theta 2, is actually equal to 480 degrees. Okay? In the third diagram, okay, same thing again. We've got the exact same terminal arm location. Okay? Now we've rotated once around and then twice around. That would be a total of 720 degrees right there, plus the 120 from before. So this would be 720 degrees twice around, plus 120 degrees, for a total of 840 degrees. Okay, for the fourth diagram, again, we've got the exact same terminal arm position, but this time we've rotated in a negative direction, okay, or in a clockwise direction. So it's going to be a negative angle. And we already know that this angle measurement here is 120 degrees based on diagram 1. And so the angle measurement, the number value for the angle theta 4 would have to add with 120 degrees to make 360 degrees total because it forms the full circle. Right? And so we know that that angle measurement would have to be 240 degrees. And again, it's negative angle because we're rotating in a clockwise direction. Now, a principal angle is going to be the angle between 0 degrees and 360 degrees that a terminal arm represents. Okay? So these coterminal angles of 480 degrees, 840 degrees, and negative 240 degrees all share the exact same principal angle of 120 degrees. Okay? So 120 degrees is the principal angle because it's the angle measurement between 0 and 360 degrees that represents this same terminal arm. Okay? Although these angle measurements also can represent that same terminal arm, they're not referred to as the principal angle because they're not the measurement between 0 and 360. Okay? The related acute angle is the angle that's formed by the terminal arm of an angle and the x-axis. So if we look in the first diagram up here, if I were to use this terminal arm and drop down a vertical line perpendicular to the x-axis, the angle that is formed in this triangle, okay, is called the related acute angle. Okay? And that related acute angle, well, because it's acute, it's always going to be between 0 and 90 degrees. Okay? Because no matter where my terminal arm is, okay, let's draw in another one. Let's say I have a terminal arm located in quadrant 4. Okay? Again, I could draw in a vertical line connecting to the x-axis. Okay? And here would be my related acute angle. So we can see no matter where we put that terminal arm on the Cartesian plane, we will always have an acute angle for the related acute, and so it's always going to be between 0 and 90 degrees. Okay, so over the next few days, we're going to be looking at using all of this information in order to fully analyze sine, cosine, and tangent ratios of all angles, not just angles that we can look at inside triangles. Okay, so now we're not limited to what angle measurements we can use because we can keep rotating to get an angle measurement of whatever number of degrees that we want. Okay, so we're going to use all of this information over the next few days to explore further sine, cosine, and tangent ratios of various angles.